Hello guys, welcome to my YouTube channel Vishwaguru, a problem solver. Today's class, we are going to discuss a numerical on the topic center of gravity. Let's go to the numerical. Determine the coordinates of centroid of the shaded area shown in figure. Here, this curve OA, which follows the equation y equal kx square. Area under the curve OA, that is the shaded portion here. For that area, we have to calculate the centroid of the area. That means area under the curve OA. It has the vertical dimension 6 units and horizontal dimension 8 units. So for this shaded portion, we are going to calculate the centroid. First of all, what we are going to do and how we are going to solve this numerical. For that, from the center of gravity by moment method, actually it's a separate video for center of gravity by moment method. That will be the reference video for this numerical. That video link I had attached in the description box. So for better understanding of this numerical, go to the description box, click the video link, center of gravity by moment method. That will be very useful for better understanding of this numerical. But whatever, at the beginning, I just going to explain how we are going to solve this numerical. Okay, that's only for reference. Finally, I'm going to erase because that portion is not for your examination. Okay, that's for understanding purpose. Okay, that is a reference that is based upon the center of gravity by moment method. This not for exam. That means whatever I'm explaining that initial case, that will erase finally, it will be erased finally. That's not for your examination. That's for understanding purpose. Here guys, whenever the area or weight, whatever is given, we know that center of gravity by moment method. Okay, so in that, if you consider W, that is the total weight of the given, it may be a diagram or it may be an object of mass or something. So W is the weight, that means the total weight of the given substance. And here that center of gravity means the X bar, same Y bar as Z bar we can take from the origin, say O. Where will be the center of gravity? At a distance X bar, that is CG. Okay, so we know that in case the weight of the that means total weight of the object is acting here, then this will be the distance X bar. So we know that W into X bar. Do you understand? That will be equal to, that means this is the moment principle. That equal to, if you consider a small strips, that means a small strip like this green in color, W1. This will be at a distance X1. So we can write W1 X1, W2 X2, etc. Then this multiple strips, we can substitute as summation of W or small w multiplied with its distance from origin. Instead of this, because the summation can be replaced by using a integration. This what method we are going to follow in this numerical. This W, that means here I'm going to take a small strip. It has a weight dW. Okay. And then it is at a distance, the small strip at a distance X from the origin. Okay. So we can say W multiplied with the X bar, total weight, and the distance of the point of, that means the center of gravity or the line of action of the weight from the origin, that is X bar. This is the moment. that equal to integral of dw multiplied with x. For the small strip, what will be the weight, and where will be the weight of the strip act from the origin, okay, in this integral. So here you can see the weight. We can write capital Mg. M is the total mass of the object. dw, that is small mg, where small m, or otherwise this I'm going to write as, okay, small m. That small m is the mass of the strip. If I replace this, we can write capital Mg multiplied with the x bar, that equal to this one, small mg multiplied with the x. So this gravity we can neglect. And then we can say mass equal density into volume. Okay. So this capital M density multiplied with a capital V, small m I'm going to write as density multiplied with the dV. dV is the volume of this considered strip. If you replace, then we will get rho V x bar, that equal to integral of rho dvx. So this rho and rho we can cancel. In case it is like a plane figure, okay, for plane figures, we don't have the thickness, that is the third dimension, which is perpendicular to the plane of the screen, plane of the paper, that will be unity. So that can be eliminated. So we can write area equal to, sorry, volume equal to area into the thickness, where the thickness equal to 1 unit. It's unity. Then instead of volume, we can say area. So dV, that equal to dA. So when I substitute here, this one, AX bar, that equal integral of this, instead of dV, dA for plane figures, dA into x. So x bar, I can write x dA divided by A. Okay. Similarly, we can write y bar equal integral of y dA divided by the A. So by using this only, we are going to solve this numerical. Do you understand? Actually, guys, what time I explained here, that you don't want to do in the examination, you can directly start to solve the numerical. This for understanding purpose. Okay. By using center of gravity by moment method, okay, from the weight we converted into mass, then from mass we converted into volume, that is for the solids. From the volume we converted into the area. From that, the x bar and y bar we can calculate. Okay. So here you can see this x dA, this x and y, here we have the equation, that means y in terms of x. For that also the value of k unknown, that we have to find. X, okay, x also we can substitute it here. So we have to find the value of area. First of all, first we have to find the unknown constant k, then we have to find the total area. Then by the integration, substituting the suitable limits, we can get the value of x bar and y bar. That is the coordinates of centroid. Okay. This is the reference. And one more thing, the reference video, center of gravity by moment method. Okay. In that we got with the summation, and we know that summation can be replaced with the integral of a single strip. Summation means we consider many strips, W1, W2, W3, their distance from origin, X1, X2, X3, then their moments, W1, X1, W2, X2, then its summation. Instead of that, a small strip, that means a single strip. For that, we get the moment, dW into X. dW is the weight of the small strip. X is the distance, or otherwise we can say this is the distance of center of gravity from the origin O. Okay. So then integration, single strip, integration, then we can elaborate true for the entire area. Okay. So by using this, weight decreased to mass decreased to volume, volume decreased to area, then X bar and Y bar. So by using this, we are going to solve the numerical. Okay. So now only we are going to start the numerical. Okay. These things and all you don't want to do in examination. Okay. So X bar, that will be integral of dA, where dA is the area of the considered strip, multiplied with x suffix x. Yes, this xs means the horizontal distance of the strip, or of the area of the strip from the origin O. Okay, divided by the total area. Same y bar equal integral of dA ys divided by the total area. Okay. So here first we have to find area. For that, we have to find the unknown constant k that we are going to find. So k. So the path equation y equal kx square. Here you can see at point A, the x value, that is 8, and then the vertical or y value, that is 6 units. It is a boundary value. So at point A, we can take the horizontal value x equal to 8 units, y equal to 6 units. Substitute in this equation. Here y is 6. So 6 equal k multiplied with 8 square. So we can say 6 equal k multiplied with 64. Then k equal 6 divided by 64. So this is the value of the constant. So we can say the equation y equal kx square. K, we have the value 6 by 64 multiplied with x square. So this is the equation now. Now, first we are going to analyze the area, because for x bar and y bar, that is the coordinates of the centroid. To calculate that, we need the value of the area. Okay. So to calculate the area of the given diagram, first we are going to consider a vertical strip as shown in figure. This strip has a thickness dx and height y at a distance x from the origin O. Okay, x from the origin or axis O, whatever. Okay. So here I just mention the dimensions. That means this is the strip from the origin or otherwise from the axis. This is at a distance x, and it has a vertical height, that is y. Okay. So it is at a distance x from the origin. It has a vertical height y. The thickness of the strip, that is dx. So here actually area of the strip, okay, area of the rectangular strip, because it is in the form of rectangle. So the rectangular strip, for rectangle we know that it is the multiplication of the two dimension. linear dimension and vertical dimension. Here the linear horizontal dimension, that is thickness dx. Vertical dimension is y. So area of the rectangular strip, the small strip, okay, area of the small rectangular strip, it is small, so we are going to consider as dA, that equal to y multiplied with dx. Okay, the vertical dimension multiplied with the horizontal dimension. For whole area, okay, area of the whole figure, then we have to integrate, okay, a, that is integral of dA, that is integral of y dx. Here we have the value of y in terms of x, so substitute it. So area, we can write integral of y equal 6 by 64 multiplied with x square. So 6 divided by 64 multiplied with x square multiplied with dx. Everything is in terms of x, and also the variable is in terms of x. Here x varies with the limit. At point O, x equal to 0. Here x equal to 0. And this point, the maximum point, where x equal to 8. Do you understand? Here x equal to 0. Here x equal to 8. So the limit will vary from 0 to 8. This 6 by 64 is a constant. So that I am going to take out of the integral. So now 6 by 64, 0 to 8, the limit, integral of x square dx. We know the formula, x power n dx, that is x power n plus 1 by n plus 1. So here x equal to 2. So we will get x cube by 3 when you integrate the equation. So area will be 6 divided by 64. That integral of x square dx, we will get x cube divided by 3, and applying the lower limit 0, upper limit 8. So first, instead of x, upper limit x minus lower limit 0. So the area of the whole figure, 6 divided by 64, when apply the upper limit, 8 cube divided by 3 minus 0. Okay, just to simplify the equation, 6 divided by 64 multiplied with this 3, this 8 cube, I just write 8, 8, 8. Okay, this 8 into 8, 64, that we can cancel. Then 48 by 3, or otherwise we can simplify 2. 2 into 8, then a we will get 16 square units. It is area, so it is unit square or square units. Do you understand? So now we got the value of the total area of the whole figure. So now in x bar and y bar equation, we have the value of area. Okay. So now we are going to substitute in that relevant equation. We are going to find x bar and y bar, which are all the coordinates of centroid. Okay. Finding xs and ys, that is the coordinates of the small strip that is xs comma ys. Here you can see, we know if it is a rectangle, from this point to this point x, and plus the horizontal dimension dx by 2, that is xs. Okay, from here to here x, that is center of gravity, normal rectangle condition, x, this dx, divided by 2. So x plus dx by 2. But here dx is very, very less comparatively x. So dx by 2 is too small. That can be neglected. So we can say xs equal to x. And ys, the vertical condition from the reference line. Here reference will be bottommost line. If it is a vertical dimension is y, then for a rectangle, it will be y by 2 as per center of gravity case. Do you understand? So the coordinates xs is x, ys that is y by 2. So now calculate x bar. Okay, we have the formula x bar equal to 1 by a integral of dA multiplied with xs. And the xs we calculated with the value x. So when I replace x bar equal to 1 by a integral of dA multiplied with x. Okay. And then here you can see, now substitute the value of dA. The dA equal to y dx. Okay, we know the dA value 1 by a, the dA equal to y dx. So y dx multiplied with x. Now substitute the value of y, which is equal 6 by 64 x square. So we can write x bar that equal to 1 by a integral of the value of y, that is 6 by 64 multiplied with x square. And then here another one x is there, multiplied with dx. So this 6 by 64, it's a constant that we can take outside. And then the area, we calculated the area 16 square units, substitute the value. Then further simplification, we will get 6 divided by 64 that I'm going to take outside, and the area that is 16 multiplied with 64. Integral of here x square multiplied with x, we will get x cube dx. It is in the form of x, and dx, the variable, x varies with the limit from 0 to 8. So 0 to 8. Okay. And then this we can simplify, and it is in the form of x cube dx, x power n plus 1 by n plus 1. So 6 divided by 16 into 64. This one, x power 4 by 4, and limits 0 to 8. When you apply the upper limit, 8 power 4 by 4 minus lower limit 0. So 6 divided by 16 multiplied with 64. This 8 power 4 by 4. Okay. Then for further simplifications, we will get this equal to 6 units. Okay. So we got the value x bar equal to 6 units. Okay. Then we are going to find the value of y bar. Here y bar equal integral of, or we can say the 1 by a integral of dA into ys. Here ys, we calculated y by 2, dA, that is y dx, substitute both the values. This equal 1 by a dA y into dx ys, that is y by 2. So this 1 by 2 we can take outside, that will become 1 by 2a, and this will become y square dx, or otherwise we can say 1 by 2 times the a integral of y dot dx, where y equal, here also we substituted 6 by 64 x square. So this equal 1 by 2a integral of 6 by 64 x square dot 6 by 64 x square multiplied with dx. So the 6 by 64, 6 by 64, I'm going to take outside, and then area, that is 16 square units, substitute all the values. Okay. So in the numerator, 6 into 6, this one, divided by 2 times area, 16 square unit, multiplied with here 164, here 164. Okay. And integral of x power 4 dx. And here also the variable will be x from 0 to 8. So the limit 0 to 8. By simplifying this, we will get the numerator 36 divided by the denominator 1,31,072. Okay. Then this integral of 0 to 8 x power 4 dx. Same x power n formula, x power n into dx, integral of x power n dx, that will be x power n plus 1 divided by n plus 1. Okay. So we can say this equal 36 divided by this value, 1,31,072. This one, x power 5 divided by 5, and limits 0 to 8. So now apply the upper limit, 8 power 5 by 5 minus lower limit will be 0. Further simplification, we can get the value of y bar. So here 36 divided by 1,31,072. Apply the upper limit. We will get 8 power 5 divided by 5 minus the lower limit will be 0. By the simplification, we will get this equal to 1.8 units. So this is the value of y bar, that is 1.8 units. So now the coordinates of centroid of the shaded area, centroid of the shaded area, that is x bar comma y bar. Here x bar we calculated 6 units, and then y bar 1.8 units. Okay. I hope you all understand this video. For more videos, don't forget to subscribe my YouTube channel, Vishwaguru, a problem solver. Okay. Thank you guys. Thanks for watching.